Okay, those online, right? I sent a file. You guys can download it into your iPad or wherever, and then we'll be using this for later on. Okay, it's just a short summary notes. Margaret, you have the worksheets? Sorry? Someone. Wait one more for the rest to come. Isaac, can I just check, right? Did you sign up for the event? Because I can't find your name under the list. Okay, and then what I need is just for you to put in the chat. Let me know your email, your surname, your email, and your number for keeping track. Yes, come in, Sec 3 Chem. Your name? Sorry? Venn. Let me see. Bennett Tan. Take a seat. Next. Xiu Hui. Lai. Lai? Okay. All right. You guys are just nice on time. Okay. I didn't go to, everybody got worksheets, right? Bennett and Shu Hui. Bennett? So the next. Let's take one and pass down. Pass it down, please. Thank you. All right, we just start now. Okay, I just go through very briefly the introduction. Okay, so welcome to our September holidays EOY revision. Okay, I'm Miss Stephanie, and I teach secondary sciences. Okay, that's why I'm here. Anyway, we have a few branches. Let's say you're interested in signing up for next year. right? There's a few branches. You can take a look which one is nearest to you or your school, right? So Central, we have quite a few like Novena, and here, if your school is near here, then yeah. Okay, but I mainly will be teaching at Coven, Novena, and Bukit Timah. Yeah. Next. Okay, this one you just take a look. Just showing you some credits. I'm not gonna read it out because it's kind of cringe. Okay, move on. Oh, you have your worksheet, so I'm just gonna skip this. Okay, we move on to the notes proper. All right, so we just quickly run through summary notes. Okay, do you guys struggle with more concepts? The smile. Yes or no? Struggle. Okay. Difficult? Doesn't make sense. Okay. So let's quickly look through the definitions. Okay, definitions, right? No choice, you just memorize. Okay, but it is just talking about the average. Let's say AR, you look at the element in the periodic table. The AR you see is just average mass, right? You compare to a carbon 12. So you think of carbon 12, right? The mass is 12 units. 1 out of 12 is just 1 unit. So compare, let's say oxygen, 16. So it's just 16 units. Okay, think of it like units. Yeah, so it's just a ratio. There is no units to all this AR and MR. Right? In your periodic table, you don't see units. You don't see grams, you don't see mole or whatever. Okay, it's just a ratio. Then for MR is for compounds or elements, like let's say O2. Then 2 times 16 lah, right? Okay. Then formula is the same. The M is just for ionic compound. The naming is different, but the idea is the same. Okay, just add up whatever you see. If you see NaCl for ionic compound, then you just add everything up together. Okay. Next, you have the molar mass. Molar mass means for every 1 mole, what is the mass? Every 1 mole. Okay. Now, the thing is that MR, the value, right, is the same as the molar mass. That means whatever MR you calculated, that is the mass of 1 mole of that substance. Okay? So 1 mole of oxygen, 16. No, 32. 16 times 2, right? 32. Okay? But this time round, because you're looking at per mole, right? Per mole, the mass grams per mole. For every 1 mole, it is 32 for oxygen. Okay? For every 1 mole, it's 32 mass. Okay, Ken? Alright. Then, you have the formula. So many to memorize. Right? Now, if you look at the Avogadro's constant, again, it is related to 1 mole. How many particles are there in 1 mole? The particles, right, is talking about either atoms, molecules, or ions. If they ask you for 1 mole of oxygen molecules, you know that exist like this, right? Molecules, then it will be this number. 1 mole of everything will be this number, okay? But if they ask you for 1 mole of atoms in O2, you have 2 times of atoms joined together, right? Then you need to take Avogadro's times 2. Your names? Malcolm Ang. Malcolm Ang and Raphael. You're just Raphael Lim. Next. Justin what? Justin. Here's a seat. I don't know. Here there's 2 seats. Ladies, do you mind? Yeah. Justin what again? Me. Okay. Take a seat. Move in 1 more seat. This your name? Hello. Name? 建浩. Okay. Y'all got worksheets, right? Okay, okay. Continue from where I left off. Okay, so again, if they ask you for 1 mole of oxygen atoms in the molecules, then you times 2. Okay, because there's 2 in each molecule. Now, what exactly is this Avogadro's constant? Okay, you think of it like a unit of measurement. Yeah, I'm gonna face unit of measurement means what? You know, a pair is 2. 1 pair equals to 2. 1 dozen equals to 12. Then 1 mole is that big number. 6 times 10 to the power of 23. Okay? So it's just a unit of measurement. If you have 2 moles, if you have 2 pairs, then you just times 2. Okay, so far? The next formula is the triangle. Mass on top, number of moles, MR. Okay? Then this is your speed, time, distance, that same triangle. Okay, the way you use it is the same. Okay? The next one you see is molar volume. Means again, for every 1 mole, what is the volume? Every time you see the word molar, it's just 1 mole. Every 1 mole of gas at room temperature and pressure occupies 24 dm cube. dm is how many cm cube? How many? 1000. Okay, this one you must know. 1 dm cube equals to 1000 cm cube. And this is at room temperature and pressure. But anyway, most of the question will ask you at room temperature and pressure. So you just memorize 24 dm cube. Next, 1 mole concentration. Okay, concentration there's 2. Mole versus the grams version, the mass version. So you look at the units. It looks like this: mole divided by the volume in dm cube. Whereas this is grams divided by the volume in dm cube. They ask you for mass concentration, go and find the mass. Then divide by volume. So easy, right? Just look at the units. Then, same for just now, the grams per mole, right? You don't know how to find the MR? Just look at the units. You need grams divided by how many moles you have. Okay? Next one. Percentage yield. Smaller number is always on top. Okay? You will never be more than 100%. Why? Because there's a chance, right, that not all reacts. So you don't get 100% yield sometimes. And then for how pure is the substance? Again, you won't get more than 100%. Right? 100% is the purest already. Correct? Okay? So why is it not 100%? That means there are impurities inside the solid or the substance. Then, so again, a smaller number will be on top lah. Last one, percentage by mass. So later on, you'll see example of this. Basically, let's say they ask you for NaCl, percentage by mass of Na, 23 times, there's only 1 of it in the whole compound, divide by 23 plus 35.5 times 100%. Okay, so that's the idea. You find how much by mass lah, by its MR, how much of it over the total mass. Okay. Now, for more questions, there's only 3 steps. The step is number 1, you always go and find number of moles using any of this formula. Usually is the triangle. Usually lah, but not always. Either the triangle or the concentrations. Usually that's how you find number of moles. Then, okay, so yeah, that. And then second step, whenever you're given or if you have written out the chemical equation, you go and find the mole ratio. And the last step is to find your conclusion, whatever the question is asking for. If the question asks you for mass, then mole ratio already, find the mass. Ask you for concentration, go and find the concentration. Okay, it's always these 3 steps. Not too difficult, right? Okay, so just remember these 3 steps. Later on, you will need it. Okay, I'll leave this here for a few seconds for those who want to copy down. Okay, then you see the next example, right? Oops. Next example, you get to try. Find the mass of each element. You are given the percentage by mass. Means in this calcium carbonate, 40% the mass comes from calcium. 12% comes from carbon. The other 48 is from oxygen. That's the percentage. And if you're given the mass of 50 grams, what's the mass of each element? Right? So you just take for calcium. Since it is 40% of the total mass, you just times 50 grams. Okay, then you go and find your own, key into your calculator, go and find the answer. Oxygen is 48% times 50 grams. Okay, what's the answer for our first one? Sorry? 20 grams. For carbon? 6 grams. The last one would be 40, 24. Thank you. Okay, I trust your math. I'm not gonna calculate it. Anyway, you add up, you should get back to 50. Is it true? Yeah. Alright. Okay, so it's correct. And okay. Next one is on how to write empirical and molecular formula. Okay, so given this, okay, although you guys haven't done it yet, right? This is organic compounds you'll learn Sect 4. Empirical formula is the simplest ratio. You just go and add everything up, then you find the simplest form. Okay? Molecular formula shows you the actual number of atoms inside, which is what you'll see here. This number should be the same. Okay? Then, from empirical to the molecular, there is this n, that constant that you divided, the simplest ratio, right? So let's see, if you have the empirical formula, the C, okay, let's use this one, n, you can find, if you know what is n, you can find this. In this case, n equals to 2. You times 2 throughout, you'll get this. Okay, so sometimes the question will give you, oh, the MR of this thing, but you don't know what is it. Let's say you don't know what is it. Then they give you the MR. So you bracket n, right? You find the MR of this times n equals to the MR of this. Then you can solve for n, like algebra. Okay. This one, the table, I assume you all know how to draw. Basically, let's say you're given C, H, and O. Usually, like the elements look like this. Percentage by mass, okay, this one will be given in the question. Okay, given in the question. Then the AR, you can find from your periodic table. 12, 1, 16. Given the mass, you divide, use the triangle again, the triangle, mass, number of moles, and MR. Or AR in this case. Take the mass, divide by the AR, you get number of moles. Okay, so whatever the number of moles is, you divide by the smallest number. Okay, then you find the simplest mole ratio. Then this is the one where I say you bracket n. Bracket n, right? Then you can find what is n. Okay. Then for ionic compound, the idea is the same. Alright, it's the same. Usually you see this kind, right, with the H2O, is because it's the crystal version. The hydrated. If you don't have the H2O, it's the anhydrous version. Anhydrous means is, let's say copper 2 sulfate, right? Anhydrous is just blue powder. But the one you see crystals means the water is incorporated into the structure. No water. Okay? But we want to know, okay, how many of these water molecules is incorporated, right? Then you just solve everything, you'll find that X equals to 5, for example. Okay, moving on. Another question they like to ask is for you to find limiting reagents. Okay, again, the steps is the same. You must first make sure your chemical reaction is balanced. Okay, that's the most important one. If this chemical equation is not balanced, your mole ratio is wrong already. Okay, so this is the first step, most important. Check your chemical equation. If it's given, then fine. Number two, you do the calculations. They ask for volume, right? Usually I will just highlight all the numbers, important numbers that I need to find number of moles. So I'm given concentration, I'm given mass. They want me to find volume. Okay, so from here, right, we know that, okay, concentration means mole divided by volume. But I don't know what is this. That's what I want to find. But I also don't know what is number of moles. But can I find it? Yes, from the mass. And which formula do we use? The triangle. Yes, the mass, the triangle one. Right? So mass divided by mR of aluminum carbonate, you will find number of moles. So you see, first step, always find number of moles. 1 mole. We have 1 mole of aluminum carbonate. And then we want to find H2SO4, okay? H2SO4. So from here, this is 1 mole. Mole ratio, 3. 1:3. Okay? 1:3. So if I have 1 mole of aluminum carbonate, I should have 3 moles of H2SO4. Second step, mole ratio done. Third step is to find whatever the question is asking for, which is volume. So you take 3 moles, divide by volume. We don't know what's the volume. This is equivalent to that 1 mole per dm cube given concentration. Then you just shift things around, you will get your answer. 3 dm cube, okay? Dm cube. If the question asks for in cm cube, then you must convert times 1000. Can? Next one. Maximum volume of carbon dioxide to be produced. Okay, now I want the product. But the idea is the same. Step 1, you're already done. Step 1, you already find mole ratio, number of moles. Then you can start from step 2 already. Mole ratio to carbon dioxide. Again, 1:3. 1:3. Third step, question asks for volume. At room temperature and pressure, every 1 mole of gas, 24 dm cube. If you have 3 moles of carbon dioxide, times 3, 72. Okay, so far? Easy, right? Now is how to phrase the excess and limiting reactant. Okay? So, for example, usually this, right, is when you're given, you can find the number of moles for both the reactants. Okay, you can find for both reactants. Like this one, you are given the mass, use the triangle. This, you're given volume and concentration, you can also find number of moles. Then that's where you compare which one has more, which one has less. Okay, so you must be able to find for both, then you can compare, ma. Okay, first step, number of moles for both, given this. Second step, based on, again, your equation, we saw 1:3, mole ratio. So from here, the mole ratio, right? How much H2SO4 do you need if you are given this amount of aluminum carbonate? So, completely react with, this is the amount of H2SO4 I need This is needed, but what do I have? I have 0.05 available. So from here, you should be able to tell I got more than I needed, right? More than needed. So H2SO4 is excess, aluminum carbonate will be limiting. So the most important step that most students miss out is this phrasing here. How many do you need? Then you can tell me which is excess or which is limiting. Okay? Moving on. Am I going too fast? Okay? Okay, Part B, again, the volume. Okay. Whenever you do limiting, right? The limiting number of moles is the one you will use for the next few parts. Okay? You cannot use the excess one because the excess not fully reacted. You have excess left over. Okay, so use the limiting, which is this one. Number of moles was, use a different color. This. Okay, then you 1:3. Using that, you will get this number of moles. Then find the volume in cm cube this time. Then you see, yeah, they converted 24,000 cm cube. Okay, so this one you must know. Use limiting reactants number of moles. Then, okay, if you think you'll forget, you just write at the side. Limiting reactants number of moles for part B. Okay, it's going to get a bit boring because the rest is just showing you how to use the formula, just in case you don't know. Okay, how to use the formula, limiting reactant. Number of moles. Use limiting reactants number of moles. Okay, next. Percentage purity, again, the smaller number is always on top. Okay. Given impure sample added to H2SO4 excess, H2SO4 produce this amount of CO2. So, you know that CO2 you got 72 dm cube. Yeah, dm cube. Okay. This means that only the pure parts of this substance can react with the H2SO4 to give you this amount of CO2. The impurities, we just assume they don't react and they don't give you CO2. Okay? So we want to find how much is this pure. What's the mass? So what you do is you reverse engineer. From this, you do step 1 number of moles, you mole ratio backwards. Okay? So first step, mole ratio, 24 dm cube. Right? For every 1 mole of gas, you have 24. If you have 72 dm cube, how many moles? 3 moles. Mole ratio backwards, 3:1. Then the last step, find the mass. Number of moles times mR. Okay? You got the mass, that means this is the pure. The only pure part that gave you that 72 dm cube. But originally you had 300 grams. Means you have a little bit of impurities there. How much? Purity times 100%. I think it's missing the times 100%, no? Okay, just add into your notes. 78%. So it's kind of pure, not say very pure, okay, but 78%. Next one is yield. Okay, this time, given this again, they tell you this is the amount of CO2 produced. Calculate the percentage yield. Okay, the thing about percentage yield is now you need to find what could be the theoretical yield. Means, in theory, if I were to react these two in this amount, how much CO2 should I be getting? This is the actual yield I got. Okay? So you need to differentiate actual versus how much should I be getting. The theoretical is just using mole ratio. Step 1, step 2, step 3 is to find the mass times the MR. I should be getting by right 132 grams, but I only got 120. So what's the yield? Smaller number divided by the bigger number times 100%. Okay, the yield is quite good. 90% is quite high. Yeah. Okay, can. So anyway, you just follow, and as long as you get the first 2 steps down, right, you get like 2-3 marks already. You just need to get to the final step, that's all. Okay, and the final step is always in the question. Okay, now it's for you to try, finally. Okay, for me to stop talking. One thing you need to know is for gases, right? Let me see if there's a question. Yeah, later on, okay, I'll go through this later on. You guys try the part A first. A and B, these two. Okay, so you're making ammonia, right? Given the mass, find how much H2 reacts completely. Why, what happened? What? Oh, there's no periodic table, right, in this? Is there? Don't have. Okay, I'll show you periodic table. I have it handy always. Can see or not? Those at the back, a bit small. I think you only need this part. Right. How come your paper still blank? Not sure. Okay, you'll continue trying first. I'll go through the steps again later on. And I'm going to go through in about 5 seconds time. Okay, so given the mass, right? Every time, the first thing you want to think about is how to find number of moles. The only thing you're given is mass, so use the triangle. Mass divided by mR, you will get N. This is number of moles of H2. Sorry, N2. Okay, N2. Then you mole ratio because you want to find H2. Based on this, 1:3. So, number of moles of H2, 3 moles. Okay? Done with step 2. Step 3 is to find the mass of H2, which is what the question wanted. You will take number of moles, so you reverse that number of moles times mR this time. mR of H2 is just 2. 6 grams. Don't forget your units. Check. Do you have your units? Okay. Then, done with the first one, right? You find H2 already. Now they ask you for ammonia, the product. You will do the same thing. First step, you already done. Second step, you just need to do mole ratio. N2 is to ammonia, 1:2. Yep, 1:2. Number of moles of ammonia, 2 moles. Step 3, question asks for mass. Your school don't allow this, right? You must write the full thing, is it? Mass of ammonia. Or M can already? Cannot. Okay, then in school, y'all will just, okay, write the full thing. But I'm okay with this. Mass in 2 times the MR. 14 plus 3. 17 times 2 is how much? 34 grams. 17, yeah, 17 times 2. Okay, the steps always the same. It's just which formula do you use. Okay. Part C and D is, the idea is the same, just that now you are given volume. When you're given volume of gases, things become a bit easier because you can skip the step. Okay, so what are you skipping? This. When you have all gases, right, at room temperature and pressure, you know that 1 mole, they always occupy 24 dm³. Okay, so you can just forgo the 24 dm³. You can just compare the mole ratio itself. Because anyway, you will times 24 throughout. So you just compare the mole ratio, right? Example, you're given 90 cm³ of H2. What's the volume of N2 required? Okay, 90 cm³ of H2. So what I will do is 90 cm³ here. Now, you just take it as doing your primary school math. 3 units or 3 moles, 90 cm³. 1 unit, 30 cm³. That means this is 30 cm³. I don't even need to do step 1. I don't need to go in 90 cm³ divided by 24 to find the number of moles. You understand what I mean? You're skipping one step, which is the first step. You go straight to step number 2 because you take mole ratio. Step number 2. You compare, right? Okay, let's say if you can't visualize this, let me write it out again. H2 is to N2, 3 is to 1. That's the mole ratio. And we say that mole ratio is equivalent to the volumes ratio. The ratio is equivalent. So if I have 90 cm cube of this, then I should get 30 cm cube of N2. Okay? So this helps you to save time. You don't need to divide by 24, then later on you find the number of moles times 24 again. Don't need. Okay, so this is the shortcut method, yeah? But let's say you cannot remember, then too bad, just do the whole thing already. Okay, you will still get back to the 30 cm cube anyway. Last part, then you do the same for NH3. Mole ratio of H2 back to NH3, 3 is to 2. Okay, so 90 is to 60 cm cube. So this here is useful if you want to save time in exam. But it only applies for gases, yeah? Only for gases. Next, we are done with the mole concept. So far, okay? Okay, yeah. So we go through all the summary first, then you get to do the questions on your own. Mole ratio from the equation. 3 is to 2. Yeah. Always look at the for equation, right? Look at the mole ratio here. 6 months. Okay. Acids and bases. Next one. This one very easy, right? Nothing new here. You learn in Sept 2, no? H plus ions, but in water, right? H plus ions. You put it in water, it dissociates. Then, basicity is, for example, okay, it's here lah. It's written here. Monobasic versus dibasic. How many H plus you get? Okay. For H2SO4, you get 2 H plus per molecule. Next, how strong is the acid? Strong acid dissociates completely, right? You use the word completely. You guys use ionize or dissociate in school? Dissociate? Okay. Or ionize, I guess, is the same. Dissociate completely to give you a high concentration of H plus ions in the solution. Weak acid will be opposite. Dissociates only, what do we say? Partially, yeah. Not completely, then it's partially. Low concentration of H plus. Okay, when we say partial dissociation, look at this. The arrow is not complete. It's the double-headed arrow. Okay, so take note of the equation. If they ask you to write, then you must use double-headed for weak acids. Strong acid is just your normal arrow. Okay. Acids, nothing much here. One more thing about acids is when you form the salt, right? The anion of the acid always become the anion of your salt that you form. You all know what's the anion, right? Means if you use HCl, your salt will end up with the name chloride. The anion will be the same. The surname will be chloride. If you use nitric acid, the surname will be a nitrate. It will still have this NO3 minus ion. Okay, anions are your negative ions. Same for this. Your salt will get your sulfate salts. Later on, we'll look at salt prep. Okay, so just take note of this. Then the first name will come with whoever you react with. Let's say magnesium, whatever. Okay, metal, then you come with magnesium sulfate as the salt. Next, bases dissociates in water to give you OH minus ion. What are examples of bases? You have your metal oxides and metal what? Hydroxides, correct. And the special ones that can dissolve in water, the aqueous version is just your alkali. So bases is like the big family. Alkalis are like small subset that can dissolve. Not all are soluble in water. Only alkalis can dissolve in water, give you OH minus. Okay. Then the strength, the phrasing is the same. Strong then is completely. Weak partially. Okay, so weak one you will have aqueous ammonia. Okay. Next. Common question. Okay, they give you a scenario where you have acidic salt. I want to neutralize the acid. What can we add in? Okay, so if you use fertilizers for your plants, right, they have the nitrogen found inside the ammonium, the N, which is good for plant growth. Okay, if you use alkali or bases to react with ammonium salts, what do you get? This alkali reaction. The gas. Salt plus water plus ammonia gas. This gas is going to escapes into the atmosphere. Then your N escapes together. So now your plant in the soil, not enough nitrogen already. Right? You're removing the nitrogen from the soil. If you're using ammonium fertilizer and alkali to neutralize the acidic soil. So what can we do instead? If I don't want to add alkali into the soil, how else can I neutralize these acids? Any ideas? Think of your acid reactions. What else can you add? Bases, alkalis, we say don't want, right? Because it's going to react. What else can we react with acids? I mean, alkali, bases is same family as the alkali, right? What else? Acid reactions, guys. Which is bases, metal oxides are bases. It carbonate or metals, right? But we don't want to put metals inside, right? Could be harmful metals, we don't want that. Carbonates is your best option already. What you get is just carbon dioxide. Okay, like greenhouse gas. Whatever. Better than harmful metals. Okay? So carbonates would be a better option because it can still neutralize the acid. The H plus, right? You get rid of the H plus, but it doesn't remove the nitrogen. Can? Okay. Yeah. Then you have all these chemical reactions below. Y'all find a space somewhere. I don't know. Let me see. Can y'all find a space? Y'all just squeeze, okay, at the bottom. Just write smaller a bit. First acid reaction, acid plus metal. Okay, I need to speed through this. I don't have time already. You get this. Okay, how to remember? Okay, I just write everything out first. Acid, bases. Third one is acid carbonates. Okay, wait for y'all to finish writing first. I'm gonna show you a trick how to remember what are the products. Let's say if you still until now you still cannot remember. Okay, So the trick is, if you're reacting with metals, 2 syllables, right? You get 2 products. Bases, 2 products. Carbonates, 3 products. All of them, number 1 is always a salt. Then the second and third one, you need to go and memorize already lah. Hydrogen gas, water, right? So water, because neutral, so that's why we call this neutralization. Acid base neutralization. Third one, water, carbon dioxide. Okay, so just take note of that. Test for gases, can I just skip? I think you guys should be familiar. Okay, I just skip. Then the ammonium one we already mentioned just now. pH, nothing new. If you're acidic, you just have more H plus. A ratio again. If you have more H plus, then you're more acidic. Okay. Then the titration, if you look at the pH curve, right, you put a pH meter inside, then you measure the pH changes. If you are strong acid and strong base, you will see a very steep jump in the pH during the neutralization. Okay, and the equivalence point will be in the middle. So this is telling you roughly where your end point is, where complete neutralization happens. Okay, but then you see for weak acids, right, and there will be this, it's not that big of a jump. Okay, but you can still see roughly where is the increase. Now, the good thing about this kind of graphs is you can tell where is the starting and ending pH. Let's say, in this case, your initial pH is very low, means you're starting off in the beaker or in the flask with an acid. Then you slowly drop NaOH, then increase pH until here you can tell it's fully NaOH because the pH is very high. Right? Compared to the last graph, you start at initial pH 3, not very high. So you know that this is a weak acid. Okay? Simple. Oops. Now, if you use weak acid and weak base, it's even more inconclusive. You won't be able to see that jump at all. It will look maybe like this. Something like this. It's like super gradual. You won't even see that long stretch. Okay, that equivalence area. So inconclusive to find the equivalence point. Next, type of oxides. Amphoteric. What is it? Quick. The Z, right? Z is zinc oxide. A, aluminium. Last one. Lead. Yeah. Okay, the Z. Next, neutral. No cold water. Okay, no cold water. Just remember like that. Neutral. Nitrogen monoxide, carbon monoxide, and then just your H2O. Okay? And it's taking longer than I expected. Okay, next one. Sorry. We do salt and QA at the same time. Okay? Take one and pass. I'm going to run through this mind map. What is it? Lead oxide. Al2O3 and then lead oxide. Okay, is there enough to go around? Yeah. Two what? Sorry? No, just this. Just this, lead 2. PbO2. But I don't think it's in the syllabus for you guys. Yeah, usually we just PbO. Everybody got the mind map? Okay, I'm going to spit through. Okay, where's my mind map? Here. We're looking at first one, solubility in water. Okay, spent salts are all soluble. Sodium, potassium, ammonium nitrate, your spent salts are all soluble. Next, chloride, Pep, Ag, Pb. So all the chlorides are soluble except for these two. Okay, Ag and Pb. Can see the pattern, right? Okay, next one is sulfates. Sulfate, you remember your sciences? You have three sciences. Physics, Chem, and Bio. Lead, barium, calcium, sulfates. Okay, so sulfate as sciences, and then you have these three different sciences. Insoluble. Carbonate is just your spar carbonates. Spar, again, we say all spar salts are soluble. Anything other carbonate, copper 2, magnesium carbonate, whatever, they are all insoluble in water. Hydroxides as well. Most of them are insoluble. Except for, again, the spar, and then you'll see these two from group 2. I think some schools will just call it sparingly soluble. Okay, so I just lump them under the soluble part. Otherwise, the rest will be insoluble. And if you have transition metals, you will see colored insoluble PPT. That's where your QA comes in. Okay, so this hydroxide ties into your QA. Because you'll be using alkalides where you get the OH minus combines with the metal oxides, give you the PPT, insoluble ones. Okay, first one, test for cations. Positive ions, right? Positive. If you have an unknown solution, you add in NaOH, you see no PPT, group 1. I think this one is not, I don't think it's printed inside. Just add in the group 1. Okay. And then, otherwise, if it's not group 1, let's say you test for the gas. You get moist red litmus paper turns blue, and H4 plus is present in that solution. Okay. You add NaOH and you get white PPT, there's quite a few different substances that it could be. Zinc, again the Zep lah, Al3 plus, Pb2 plus. Okay. Otherwise, this white that's insoluble, you will get Ca2 plus. Okay, so colorless soluble and colorless solution is the Z. White but insoluble is Ca2 plus. Then PPT green insoluble is iron what? 2 plus, yes. And then reddish brown will be iron 3 plus. So you think about the rust, right? Rusting is like this reddish brown color. This is the iron in rust, the 3 plus charge. Light blue, there's only one light blue. Copper. Okay, so the blue one very easy to remember. So only this 3 is the colored one that you need to remember. So very easy. It's the white one that's the problem, right? You got so many that is white. So how to distinguish them? All these 3 is the same, right? You go to the next test. You add aqueous ammonia. That will help you separate them out. Okay? Add aqueous ammonia, no PPT, calcium, ammonium, group 1 cations. Then this is the distinguishing part. Aqueous ammonia, you get white PPT, dissolves in excess, colorless solution, Zn2+. If you still see white, insoluble, that means it's the other two. Either Al or Pb. You guys still learn Pb, the lead one, or just aluminium only? Just aluminium. Okay, then you just ignore the lead one. Then aqueous ammonia will help you distinguish between zinc and aluminium. If your school needs Pb, means that you need to do the additional test, extra test, to further separate them out. This extra test, you add acidified, either iodine, chloride, or sulfates. Okay, why? Because if you go back to your solubility table, lead chloride is insoluble, sulfate is also insoluble. So you are making use of this solubility table to take out a PPT that can help you distinguish it. Okay, so you add either chloride or sulfate, no PPT, aluminium. If you have a PPT, it is a lead-2 PPT. Yellow means it's lead-2 iodide. White is either lead-2 chloride, which you saw earlier, or lead-2 sulfates. Okay. Then you see the same three colors again. The sequence is the same. Green Fe2+, reddish brown Fe3+. The only difference now is copper is still light blue, but if you add in excess, you get dark blue. Yes. Then you know it's Cu2+. Honestly, the moment you see light blue, you know already lah. Okay? Done with cations. Move on to the anions. Yeah, anions. First one, alkali plus aluminum fall and warmed. The gas evolved is again ammonia gas, but now you're testing for anions. The anion present is a nitrate anion. Okay, so just remember the N and the N. Next one. If you don't add alkali, you will add acid. This acid, do you guys know what is it for? Carbonates. CO3 2-. Effervescence will be produced. Make sure you spell effervescence correctly. Colorless, odorless gas. So if it's a carbonate, you know like acid-carbonate reaction, you get carbon dioxide gas. What is this white PPT that you see? The carbon dioxide bubbled into lime water. And you see that murky, right? In primary school, you see murky, cloudy, but we don't call it that anymore. White PPT is called calcium carbonate. The solid, the white solid that makes it murky. Okay. Now, after you've done the first step, right? It's always to make sure that you remove all the carbonates. If it's an impurity, remove it. Okay, so it reacted away. Now, if you have any other anions, you will test with all this. Okay, so the first one is to add silver nitrate. So you see silver again, Ag. Ag mixed with what will give you PPT. Then you go back to your solubility table. Silver chloride. If you see a PPT and it's white, it is silver chloride. Okay, for this test lah, specifically. So white PPT, Cl minus is present because this is AgCl PPT. If it's yellow, I don't know if your school y'all got learn iodide? Okay, then yellow I minus. Then it'll be AgI. Okay. Now, why I didn't highlight the lead 2 nitrate is because you see that you get both white PPT, which is this one lah. The lead 2, right, with chloride, with sulfate, you get both white. Then how do you tell which is which? So, if you were to use lead 2 nitrate and you get white, right, you won't be able to tell which is the anion. Inconclusive results. So the best is try not to use lead 2. Use the highlighted ones. Okay. So we prefer the orange highlighted one. Okay, because barium, only the sulfates will give you white PPT. And then silver, only the chloride and iodides will give you white PPT or yellow PPT. Okay, so preferred would be the highlighted one. So use barium. So barium is always for sulfate. Silver is always for the halides. Okay, can? Why is that so, right? It's again based on this. You see the barium is always with the sulfate. The silver is always with the halides. Okay, done finally. Then, can I just leave this here for whoever needs it? Can you flip? Let me see the notes. Where are we? Okay, done with QA, right? Okay, I want you guys, right, to find page 14. Page 14 of your notes, right? Page 14, you flip to this page. The page after 14. You will see this mole concept, acid and bases. We do this one first, it's shorter. Okay? So what's the time? 8 o'clock. Okay. Okay, so you guys start with the MCQ first. Go to page 14 and flip. This one. There's only 5 MCQ questions. You'll just quickly finish it up. Maybe give you guys 8 minutes. And then we'll go through. Okay. Question two, you change to potassium hydroxide. Yeah. If you avoid PC, you get even more, right? So this 50, if you add more, this 20. Yeah, but you look at the first color first. And okay, there is a 50, then this is the first combination. Then this will be the second. If you add it. So some will dissolve, then some will not. That's how you dissolve. So for more question, always use the 3 steps. Let's say if you're stuck. You have about 3.5 minutes left to finish 5 questions. One minute left. Just finish as much as you can, okay? As much as you can. T21 hours Just finish up your last question, whatever that you're doing now, right? Just finish it up and then we'll just go through together. Okay, if you can't finish, we just do together. Okay, another 10 seconds. Meanwhile, you can check your first question. You should have gotten B. Anyone needs help with question 1? B. Okay, you take 72 divide by 24, you will get number of moles. First step, done. Right? Then they just ask you compare the same number of moles, right? Just find one that also has 3 moles of whatever substance. Yeah. Are you doing the one right at the back? You flip to page 14. Page 14 from the beginning. Yeah. Okay. Then for question 2, same thing, do number 1. Find number of moles. After you find number of moles, mole ratio times 2. Mole ratio. Potassium, right? This one, potassium hydroxide. And then find the concentration. Once you have gotten number of moles, 0.004, divide by this, but dm cube. Must change to dm cube. Okay, must change to dm cube. Because you see all the units is all in dm cube. So maybe some students will miss out step 2, which is the mole ratio 1:2. Or you miss out the 25, divide by 1000. Option A. Everybody okay? Usually for when I do mole concept, I will just, instead of writing out, oh, number of moles, blah, 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 I will just do this. Save your time. MCQ, you don't need to show working, right? Okay, so you just do this. Question 3, you should have gotten C for those who have done it. Okay. Now, this question 3, you will do the shortcut. Do the shortcut. Because gases are involved here. Do use mole ratio equals to volume ratio. So the water is liquid state, then you don't use, okay? Don't care about it. They want total volume of gaseous products obtained. So gaseous product, you only have this, so you'll use the shortcut. If you are given 0.05 moles of ethane, C2H6 is to CO2, 2:4, 1:2 ratio. Right? Then, okay, if you have 0.5, It's just 1 mole lor. If you take this times 24, and then you do the ratio, you will get the same answer. Okay? CO2 is 1 mole. And 1 mole occupies 24 dm cubed. Question 4 should be quite easy. Right? Question 4 should be quite easy because which one will not give you a gas? Oops. This one will give you hydrogen gas. This is neutralization, acid alkali. You get water, not a gas, liquid. Carbonate, confirm you will get a gas. This one, the ammonia, the one that escapes from the salt. Next, question 5. pH indicator. Solution X, pH 13. Yes? Why? pH 13 means it's very alkaline. Guessed it right. Nah, I got nothing to say. Okay. Now, colors of the solution. Alkaline, right? Then you just here lah. Give away. Come on, it's in the table. Alkaline, pH 13, blue and red. So easy. Okay, let's take a 5 minutes break before we move on. Snacks are at the back. If you need. It's on the white shelf at the back. If you need to go to the toilet, just go now. Oh, it's there inside all the way. Yeah. Okay, this one right is in. It's not the first. It's under. For example, this. Anyway, ammonium, right? Yeah. Ammonium chloride is ammonium salt plus alkali. You get the salt plus water and the gas. It's always salt plus water plus gas. This is only for alkali with ammonium something. Always you will get these two things. Then the salt depends lah. Okay? Yeah, so you go back to that question, right? It's the same thing. See? NaOH, then ammonium something. So don't care about this. Just you, the moment you see ammonium and alkali and water. This plus water and salt. Yeah. It's all the way inside, but I think someone is using, just queue up. There's only one toilet. Getting review. Helping me get reviews. Later on, there's Google reviews. And then, wait, I need to find. Yeah, the physical paper. Wait, I need to find the. I don't know where's the physical paper. Let me find.
I can't remember. Oh yeah. I grew up not moving. I'm talking about saying. No, but don't let it find only if not right so far. I don't know when my total sorry. Actually, she's gonna be same day.
1 minute left.
One year ago, my grandma, because then she told me this.
You guys are not overmugged students.
I'm a mother. Mother's calling to stop.
Okay, those who are back, you can start on question 6. You got time to try first, okay? Try. Calculations again. Do the 3 steps. That's all. Very simple. Jasmine will print next time, right? Yeah. Okay, let's start on question 6. Yeah, question 6.
I see also differentiate from the
If you're still not sure, then you go back to the notes and find that page with all the formulas. You would use one of them at least. There will be at least one that you need to use. Question 6.
Okay, so how many food? What kind of food? How many is 600? Which will become 600.
Can't be too difficult, right? Hey, if you're not sure, just go to the formula, right? If you're not sure, just go to the formula.
Don't CMT to GMT1. Oh, meter to 10 kilometers per meter time become. Yes, smaller. You find volume, then you find holes. What? What are you yapping about? What? Huh? No. Why is 600? Oh, my bad. I thought it was.
What is going on, guys? Please, this is only at part A. It can't be that hard, right? If you're done with A, you can move on with B and C, of course, if you're fast enough. But I will show you a shortcut for part A later on. There is a shortcut. Yeah, literally. You should be at least done with A. At least.
Remember my work was
Okay, our normal flow is to find number of moles first, right? You will take concentration mole over volume. Use this formula. You are given volume, you are given the concentration, you can find number of moles. That is the normal workflow, right? Then you just do mole ratio, blah, 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 blah. Okay, but anyway, now they are just asking for concentration, but in mole per dm cube, no longer grams per dm cube. So the shortcut is this. You see the grams per dm cube, right? Then you want to convert to moles per dm cube. What you can do is divide by grams per mole. Does this grams per mole look familiar? It is the molar mass. Divide by mR. What will you do when you divide? You cancel out the grams. You're left with mole per dm cube. You can see? You divide, you reciprocal, right? When you divide. Yeah. Okay. So the shortcut is just divide by grams per mole, which is the mR. Which is what I've done here. You will get 2 moles per dm cube. Did anyone get this? 2. This is the shortcut lah, okay? Shortcut. Then if let's say they give you mole per dm cube, ask you to convert to grams, you do the other way, just multiply. 10. Okay, given the concentration, again use concentration equals to mole over volume. You have the volume, you have the concentration here, find number of moles. Just bring over 2 times 600 divide by 1000. dm cube. Convert to dm cube always. Then you get 1.2 moles. Okay, so this is essentially now your first step already. Number of moles done. Then part C is asking for step 2 and step 3. Step 2, mole ratio to find hydrogen from 3:3. You simplify as 1:1 lah. Okay, 1:1 ratio. Step 3, find volume. Volume times 24. 1.2 moles times 24. 28.8, don't forget your units, dm cube. Okay. Is that all done? If you're done, you can move on to question 7. Do part A, go and identify. They love to use this kind of flowchart questions, so you must know how to do.
Because of that, that's what
You need periodic table or what? Don't need, right? This one? This question don't need, right?
Ammonium carbon.
Where did that huge cookie come from? This is from Subway or what? Done. Can we? Is it difficult? Let me see.
Ammonium carbon. You add any H, okay? This is H will give you kind of solution if you ammonium. Ammonium carbon. Ammonium carbon. The carbon makes CO2 that. Yes. You want to ask him?
One last minute, 1.5 minutes left.
Wait, ask him for gas. Gas. No one's asking for gas. We need contribution.
If you're done, you can move on to B first while we wait for the rest.
Ammonium carbonate, hypochlorite.
Okay, 10 seconds.
Gas key. The only one has a gas key is carbon dioxide. Make carbon dioxide. Therefore, it's carbon dioxide.
All right, let's go through. Now, we start off at the beginning solution F. Okay, when you add alkali, you get salt, water, and gas. There's too little information. We don't know what is going on. When you add solution L, you get ammonium salt plus water plus carbon dioxide gas. Okay? Then there's only two things that react together to give you ammonium salt. What is it? Alkali plus another ammonium salt. So F and L would be either of this, but we don't know which is which yet. Then you think to yourself, if F is ammonium salt, will it react with H2SO4? No, you didn't learn any of the reaction. But if let's say H2SO4 with alkali, will you get a gas? Will you get a gas? No. Then how? That means something in that salt can react with acid. Not the ammonium, but it's the inside, the anion. Okay, so F must be that ammonium salt. Therefore, L is the alkali. Is it? Wait. Am I tripping? Am I? Okay, wait. Then, okay, we move on from there first. To give you salt plus water plus carbon dioxide, when you add acid, right? What is the one that gives you, acid reaction that gives you this gas with 3 different products? Remember the 3 syllables one is which one? The carbonates means it's an ammonium carbonate. Right. So F is ammonium carbonate. They want a chemical formula. If you write the name, 0 marks. 0 chemical formulae. That's why I highlight. I know this will be, you want to listen to him, right? Then you all get wrong. Chemical formulae. Okay, if you until now you're still not sure how to write chemical formulae, CO3 2 minus, you take the charge, you cross downwards. NH4 bracket 2, cross down. CO3, the 1 cross down, don't need to write. Okay, so that is ammonium carbonate. Okay, then L is am I tripping? L should be Yeah. J is ammonium sulfate, right? This plus H2SO4, you will get alright, J is this and K is this, right? Oh, okay, I know where I'm tripping. It's this one. Switch, okay? Should be here. This. Sorry. This should be here. Alkali plus ammonium salt. Then you get gas H will be the ammonia gas. Yeah. Okay, the ammonia gas. Then you know that F is ammonium carbonate already, right? Ammonium carbonate plus something to give you ammonium, another salt. Okay? Then for the salts, the anions always come from the acid. So if it's a chloride, means L must be a hydrochloric acid. So you should get this for your answers. G is on top, okay. Ammonium. Okay, so G I haven't finished yet, right? NaOH plus this. Oops. You will get salt plus water plus ammonia gas. So now we need to find what is this salt. The trick here is this will become the ammonia. This part will become the water. What are you left with? These two things. Na2CO3. That is G, salt G. Because Na is Na plus, right? Then CO3 is 2 minus. So when you cross down, it's Na2 CO3. Okay, Ken? Okay, move on. Describe a test for H. What's H again? Ammonia. We will use ammonia gas. What? Moist what? Red. Confidently moist blue. Moist red litmus paper. Because why? NH3 is alkaline, right? Then you always use the opposite one. The red one, test and it will turn. Moist red turns blue because it's alkaline. Confirming that it is NH3. Okay, then the chemical equation is just acid and carbonate. So nothing too difficult. So you can just copy this one down. It's the alkaline one, the ammonium and alkaline one that most students will be a bit confused. Okay, but this kind should be quite okay. Just acid, carbonate, 3 different products. Salt, water, carbon dioxide. What chicken? I don't know what's going on. It's 9. Okay, we need to. Hmm. Okay, can I move on? Okay, I gonna shift already. Question 8. Okay, we just quickly run through. I want basic acidic amphoteric oxides and neutral oxides. Okay, so those that can react with acids, then obviously it is basic. If can react with alkalis only, then it's acidic. Can both amphoteric, non-neutral. So go to the table. Amphoteric is which ones again? The zinc, aluminium, and lead. Zinc, aluminium, don't have lead, then forget it. Okay, so those two are your amphoteric oxides, so fill it in. Basic oxides are essentially your bases. Bases are, how do you tell if something is a base? Acid? Metal oxides. Any other metal oxides that is not the Z. Example, sodium oxide, calcium oxide, copper 2 oxide. Not Z, but they are metal oxides. Okay, so you have those 3. Then next one is acidic and neutral oxides. Neutral is which one? Which 3? CO, NO, no cold, H2O, no cold water. So CO, neutral. The rest, non-metal oxides. That is not the 3, they are acidic. Non-metal oxides mostly are acidic except for the 3. Okay, so question 8 done. Simple. Moving on. Done already, right, with this one? Okay, then that means we are left with the front portion. That whole front worksheet is quite calculations heavy, if I remember correctly. Anyway, for more concept, right, you just keep practicing non-stop. You will get used to it, right? All the formula will all be in the break. Okay, you don't even need to refer anymore. Okay, the moment you see more concept, just do number 1, step 1. Okay, we skip the MCQ first, okay? If you have time, we go back. Go to page 6. And page 6, question 11. We do the open-ended first because I think that one is more difficult. 11 of page 6. Okay, this one is a little bit more difficult. Okay, so I want you guys to try first the part A at least, part A. Read through the question carefully, okay? What's going on? Why? Why? Difficult or what? Don't understand what's going on. It is a bit confusing. Okay, this one is, I think this is the toughest question in this whole worksheet already.
Yeah. No. No. Ui,我就是没确定了。
There's the water cooler there. You can go and refill. Forgot to tell you guys. Okay, can part A. Okay, essentially what is happening here is that you just look at the first, this part here first. Okay, 1000 dm³ of air you take out, bubble through sodium hydroxide, right? Because the air is supposed to contain this sulfur dioxide. We don't know how much, okay? But anyway, bubble through sodium hydroxide, resultant solution, you dilute, okay? So that 200 cm³, whatever that is left, you just dilute to add up to 1000, okay? With distilled water. You just topped it up all the way to distilled water. And then From here, right, this 1000, they say 25 cm cube was taken out for titration. So from this 1000, you take out another small batch, 25. This one you all can visualize, right? Okay, from the big beaker, you take out only 25 because your burette cannot fit so much. So you just take one sample out, small sample for titration with this amount of hydrochloric acid. Question, calculate the total number of moles unreacted sodium hydroxide. Where is the unreacted? Is inside this resulting solution, which you topped up to 1000, which you then take out 25. Okay, yeah. From there, just work backwards. Okay, these kind of questions, you just work backwards. You reverse engineer a bit. You start from the back with that hydrochloric acid. How many number of moles? You work backwards. So, okay, if you were to write out the equation, because mole ratio, we need balanced equation, right? H2. Everything 1:1 ratio, fine. Then, first step is to find number of moles as always. This from here, you have volume, you have concentration. Everything you need to find number of moles. You should have gotten 0.02 for HCl, okay? HCl. Step 1, number of moles. Step 2, mole ratio. Okay, mole ratio. 1:1. So number of moles of NaOH, you get Sept, 0.02 moles. From there, this 0.02 moles belongs to what you use in titration, which is only in 25 cm cube. Total number is in that 1000. So, if 25 cm cube contain this amount, 1000 contains 0.08. You reverse from 25, right? Reverse backwards to the 1000 also. Just keep working back. Then? Confused? Okay, I say again. Out of this 1000 that you topped up, inside has all the unreacted sodium hydroxide. Unreacted. Okay? This unreacted sodium hydroxide, from the 1000, you took out a sample of 25. And this 25 exactly reacts with this amount of hydrochloric acid. So you can do mole ratio 1:1. This is the amount of NaOH in that 25 sample. Only a small amount. 0.002. 20 divided by 1000 times 0.1. Someone calculator, please. 0.002. So I'm missing 1 0. Is that right? Is it correct? Missing 1, Okay, then y'all just add in. Then here will be 0.008. Times 40. Is it 40? So your answer is still 0.08 lah. Okay. So from there, this is the amount in the small sample, but you have 1000 in total. You get back to the 1000 cm cube. What thing? Cm cube. In 25 cm. Yeah, I'm about to crash out, guys. Please. It's like 9 p.m. I can't. 1 unit. Okay, it does look like 1 unit. I'm sorry. Okay, my handwriting. This. It does look like kind of like 1 unit. Okay, I don't blame you. Okay. Then, right? You know that inside here is all the unreacted NaOH. So, in this air that was bubbled into sodium hydroxide, some of it reacted with the sulfur dioxide. Remaining is the unreacted NaOH. Okay? Okay? Okay. Then, they want to know how much reacted away with the sulfur dioxide. If you know what is the unreacted, which is here, right? 0.08, and you know total, you started off with how much? You take total minus this one, you will get the reacted. So again, total minus unreacted, you get reacted amount. Okay. So total is how much? Given here, 200 cm cubed times 1. 200 over 1000 times 1 minus unreacted was 0.08. You will find your reacted amount. Okay, so this one is just shortcut version because we don't have much time left. But anyway, the long version looks like this. Okay, so this amount would be, this one, 0.2. Then you take 0.2 minus 0.8. 0.1 to reacted. NaOH that was reacted. Step 2 is to find mole ratio. You want sulfur dioxide, not sodium hydroxide. So go to the equation given. 2:1. 2:1. Are you guys still following? 2:1. Then just divide by 2, you get sulfur dioxide number of moles, 0.06. Okay, 0.06. Not done yet. Okay. They want the percentage by volume. Not by mass, by volume at room temperature and pressure. This one, you definitely can find the volume of sulfur dioxide. Question is, what is the percentage? To find the volume, just take number of moles times 24. Okay. Then this percentage, what do we divide by? Confused still? Who? Someone is still confused. Percentage by volume of SO2. Can someone find this? What's the volume? In dm cube. Key into your calculator. 0.06 times 24. 1.44. Okay. Then, what do we divide by? What's the total? That was from the sample of air that you took out. That 1000 is the total. Out of there, you have 1.44, which is sulfur dioxide. Not a lot, but enough to cause acid rain. Then you will get your percentage. You should get 0.144. Okay, originally, the plan was for you guys to try out the whole entire worksheet on your own, but we don't have time. Right? And it's going to take too long. So we move on. Question 12. We try to finish as much as we can. If you cannot, there will be the answer key distributed. Okay, you all later just scan the QR code. Question 12. Empirical formula is where you draw the table. In exam, I don't think they'll give you the table. You have to draw everything out yourself, okay, in your own exam. But if they do, then great, because you just need to put in the numbers. Percentage by mass, percentage by mass. Just slot it in. AR you can find from the periodic table. Potassium is 39, iron is 56, oxygen 16. From there, find number of moles. Take mass divide by the AR. And we always leave in 5SF first. Calculations, right, in between 5SF. Only the final answer, 3SF. Okay? Then from here, you find the smallest one is this. You divide everything by this number, smallest ratio. Then if you get a 1.999 something, you just round up to 2. Okay, like the first one, we just round up to 2. Same for the last one, round up to 4. So this will be your empirical formula. The simplest ratio. But is this the molecular? We don't know. Okay, we don't know. So this is... So after you do the table, you cannot leave your answer like this. You must conclude. Empirical formula equals blah, blah, blah. Okay? Part B. This one okay? Part B is related. They give you equation. They tell you it is going to react. Okay, to get this right, you need these 3 things to react. Okay? Given 1 grams of this added to this amount of KOH. Find the limiting reactant. So what did I say about limiting? When you can find the number of moles of both the reactants, which is what you can do. Number 1, number 2, you can find both. Then you can compare who is more, who is less. Okay, so step 1, find number of moles of Fe2O3, mass divided by MR. Okay, 0.00625. Then find number of moles of KOH. You are given concentration equals to mole over volume. You want to find this. Bring this over. Volume times concentration. 2 times 20 over 1000. Okay, this one you will need to find later on. Okay, the available one is here, okay? This one. Shift things around first. You find the number of moles for both first already. Then you do the mole ratio. Okay, so here is step 1. Step 2 is mole ratio, 1:10. So take 0.00625 times 10. This is the amount of KOH needed. How much do I have? Is it enough? So that is the question. Then your concluding statement would be, okay, you need to conclude with a nice statement. Is it enough or not? KOH, you need 0.06, but you only have 0.04, right? So not enough. KOH is your limiting reactant. So we will say that 0.0625 moles of KOH is required for complete reaction with 0.00625 moles of Fe2O3. but only 0.04 moles was available. Hence, KOH is the limiting reactant. Okay, so this concluding statement will give you your final mark. Although it's a little bit long, but it's easy, okay? Easy to get that 1 mark. Okay. Now, once you know who is the limiting reactant for part B, you want to find the mass of this. Yeah. The mass of this compound Z. Whose number of moles do we use? Fe2O3 or KOH? The limiting reactant. Number 1, mole ratio. Number of moles you already know. Number 2, mole ratio. You should get 10 KOH is to 2 of Z. 10 is to 2. So use this for part 2. 0.0625 divide by 10 times 2. Is it? No, 0.04, sorry. The limiting one. KOH available. Okay, available. Divide by 10 times 2, 0.08. Then, third step is to find what the question wants, which is mass. Multiply by MR. 3SF 1.58 grams. Those who are done, you can move on to question 13. Go, go, go. Move on, huh? Acid reactions. Okay. Shouldn't be too difficult. You can try part B also if you're done with A. Just tick, that's all. Part B is just ticks. Okay, for part A, only peanuts grow well, then it should be within, must be before this 6 lah. 5.5 to 5.9, any number. Predict just one. Don't need a range. And then grow well in the same soil, which is the acidic soil, mango. Okay? Next, for part B, the best growth fertilizer is ammonium sulfate. Okay? So again, when you think about fertilizers, you want that nitrogen to not escape. Okay? And then we also want to make sure that you neutralize the acid inside the soil. So there's like two things you need to think about. Will it affect your plant growth because of the nitrogen? And will it be too acidic? Okay? So we mentioned how, okay, instead of using alkali, carbonates will be the best option because it will not react with the nitrates are still inside, nitrogen still inside, and it can still react with the acids. So it controls the pH. So this is your best option. But let's say if you don't have carbonate, then too bad. Okay, use alkali. But your plant will be sad because the nitrogen all escape. Okay, escape as ammonia gas. The nitrate itself, there is the N inside here. You add in, then of course, yeah, your plant will pick it up, but nitrates don't react with acids, right? They don't react with acids. React with acids. So you won't be able to control or lower the, basically remove the acids, but you optimize plant growth. Whether the plant can still survive in the acidic soil, we don't know. Okay? So the best option is always to use carbonates. Alright. Done with this, move on to question 14. pH curves. So we are given this amount of hydrochloric acid added from a burette. Okay, now when you see titration, the important thing is you must know what is in a burette, what is in your conical flask. Okay, so this will be in a conical flask, which is where you put the probe in. That's why the pH starts off at 13. Initial pH 13. Right? From there, from the burette, you slowly drip, 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 hydrochloric acid neutralize. Okay, strong acid, strong base. You will see a sharp drop. And the equivalence point, you should know exactly at 7. Equivalence point. Right, because the salt you make is neutral and plus water. So everything is neutral, pH 7. But anyway, you will see this steep drop. That means the moment you add burette, right, you see the color change. That add one extra drop of HCl, it will totally go down to the pH of your acid. That one extra drop makes that whole neutral solution acidic now. Okay? That's how you know, okay, stop. Don't add anymore already. You have reached equivalence point. Experiment 2, they instead of using alkali or base, they are using carbonate. Okay, then you see, well, what is going on? What is this? There are 2 definite steps. Means you have a step-by-step neutralization. 2 neutralization happening one after the other. How does that work? Okay, they will tell you later on. You will see here, stage 1, stage 2. That's where you get the 2 steps. So what happens is that sodium carbonate reacts with the acid to form sodium hydrogen carbonate. Okay. This is the second acidic H that has to be neutralized later on. The first H came from your hydrochloric acid, number 1. The second H comes from this salt that you made, this sodium hydrogen carbonate. It itself can dissociate 1H plus out. That's why you have the second step. Undergoes further reaction with hydrochloric acid. Sorry, this should be HCO3 minus. Okay, because this is Na plus, then this will be the anion that reacts with HCl. Okay. Then from there, okay, we look here, right? You have 3 different pH indicators that you can use. The best indicator for titration gives a distinct color change during the step. That means you must find a pH indicator that will change color during either here, here, or here. Okay, that's what the question is saying. During the step inside. Experiment 1, all is suitable. Then, from figure 14.2, find sodium hydroxide's pH. Not hydroxide, hydrogen carbonate's pH. So, you made this salt after the first neutralization. In between here. Okay? Sodium carbonate plus HCl, you get this sodium hydrogen carbonate salt plus the other salt, NaCl. And it's all inside here. What is the pH of this whole entire solution? You know that this is neutral, NaCl is neutral. So whatever pH must have came from this. Anywhere in between here. You don't know where, but somewhere in between. Okay, so about 8.8 or so. Just suggest 1 within that range. Okay. Then find a suitable indicator that will show you this stage 1, where is the endpoint. So again, the indicator must fall within the same range lah, essentially. 8.8 to 10.4. So you find 8.8 somewhere here already. To 10.4 somewhere here. The only one that changes color is this. Colorless to pink. Or pink to colorless if you're going downwards. Okay, so phenolphthalein is the one we will use. The next question. Balanced chemical equation. Okay, you guys try the chemical equation. Next one. Once you're done with this, then you move on to the next one. With state symbols also, right? If you're not sure what is the state symbol, you go to the solubility table. Is it soluble? If yes, then it's aqueous. If no, then it's probably solid already. Okay, Ken? Silver nitrate. Ag plus nitrate is NO3 minus. Then just NaCl. Ross? What is this method? When you mix two... Okay, first of all, AgNO3, is it soluble? All nitrates are soluble. So AgNO3 aqueous plus NaCl, you know, confirm this stable salt confirm will dissolve in water. Aqueous also. When you mix two aqueous solutions together, what is this method called? Precipitation. So you are bound to get one solid and something else. Then you check. Every time you see precipitation, right? You take out the ions, Na plus, Cl minus. You exchange the partners. They swap partners. Na plus with NO3 minus, you will get NaNO3. Is this soluble? Sodium nitrate? Yes, because all nitrates are soluble. So this is the aqueous salt. Then the next one you mix is Ag with Cl. What do you get? Which is the solid. It is insoluble. The white PPT. So at the end of the day, you should get this. Everything should be balanced already. 1 is to 1 is to 1 is to 1. Now, once you're done with part A, right, I want you guys to take out that solubility worksheet again. We just quickly go through salt prep. Okay, salt prep. If it's a spa salt, we will use what method? You remember? Okay, salt prep, there's only 3 methods. P, E, and T. For spa salts, we will use titration. titration. Because you need exact amounts. You cannot have anything more, that will be impurity already. You need exact amounts. So titration is your best bet. Then, just now we also look at precipitation. That's for your insoluble PPTs. Precipitation. And for precipitation, just now we mentioned you must have two solutions using two aqueous solutions. What is that last E step? Excess what? Adding excess insoluble solid to what? This solid is going to do what? React with acids. Insoluble solid to this is for all soluble salts that is not spar. Not spar salt. That means like copper 2 sulfate, for example. You can use the E method. Okay, so spar is titration. Soluble but not spar, E. Last one is insoluble precipitation. Okay, so the E is the excess. You want to add in excess, make sure all the solids reacted. Okay, done with this. Back to the question. To get the silver chloride, the student omitted a step. Okay, so after the precipitate forms, he filtered. Okay, good. Get the residue ready. And then also get the filtrate, heat until saturated to get sodium nitrate crystals. After the crystals, what do you want to do usually? Rinse and pat dry. But before you rinse, you must get out the crystals, ma. Saturation, right? When you use crystallization, you have still a little bit of the liquid left. So you must still filter out to get the residue crystals. Okay. Okay, for silver chloride, also the same thing, the residue. If you want to collect, you must rinse and pat dry. You need to rinse. Rinse with distilled water. Get rid of any of the filtrate that is stuck on it. Okay, so he's missing this extra step in step 2. Okay, done? Now, for part C, if you collect this sodium nitrate, right, from this method, which we said was precipitation, right, why is it most likely not pure? Sodium nitrate by right, if you want to collect, which method do we use? Sodium salt. Titration. By right, you should be using titration because it's a spar salt. But if you use precipitation, they're saying it won't be pure. That means you have additional of something that came together with the crystals. So, just now we say titration you use because you want to add how much? Exact amount. But now, you can't tell if you are adding exact. So what you do is, with the information, you try to find, did you add in exact? Find number of moles. You should get this. Okay? That's the number of moles. And based on your equation, should be 1:1 ratio. But you have more of something else. Too much. In excess. This is in excess. Okay? By right, it should be a 1:1 ratio. But silver nitrate is in excess. Means when you try to form this sodium nitrate, right, which is a sparse salt, you have excess silver nitrate that is mixed in together with it. That makes it impure. And you don't want that. Okay, so when you collect sodium nitrate, it is not totally pure. So that's the reason. Okay, so to write it out in words, silver nitrate was added in excess. Contaminated with, okay, so you check, right? You have Ag plus and O3 minus, right? Then the sodium, you have Na plus. What you wanted is just this. But now you have an additional Ag plus ions inside, which is not what you want. So it's contaminated. Okay, then we also mentioned the proper method we should be using. Titration. Okay, then you go and find what should we use for titration. So titration, usually we use what? In your burette, in your pipette, what do we usually put? Not sure. Okay, basically for titration, you will choose one acid plus either alkali or must be a soluble carbonate. Why soluble? You want to put in your burette or pipette, right? How to be solids? Cannot. So it has to be in aqueous form. Everything in aqueous, right? Then you cannot use metal acid reaction also because metals are solids. So your best bet is either alkali or a soluble carbonate. If you can, just go with this, the easiest one. So you find sodium nitrate. Surname of salt always come from the acid. So we will use nitric acid. Chemical formulae. And then the other reagent, what can we use? Sodium hydroxide. Because the first name comes from the other party, which is the alkali. Then alkali with sodium, just sodium hydroxide. Okay. Done with this. Then you try the flow chart. Again, identify it. Okay, now it's QA. Use the mind map to help you. Okay, find the cation ions or anions or whatever. They want the precipitate. They want the precipitate, not the ion present. In the flow chart, I'm just showing you the ion. Okay, Fe2 plus, Fe3 plus. But the name of the insoluble solid is when you have the cation mixed with the OH from the hydroxide. Okay, so it's an ionic compound. It's a solid. That means you find the cation, let's say Cu2 plus, then you cross with OH minus from the alkali. Find the precipitate, for example, looks like this. Blue PPT, example. Okay, so if you see green or reddish brown PPT, then you find the cation, you cross with OH minus. Okay, this is the last question already. We're almost done. Iron 2, iron 3, what? What is the full name? Name, not formula. Name the following. The hint is here. Right? With Cu2 plus with the hydroxide from your alkalis. So it's iron 2. Huh? The blind leading the blind or what? Zero, zero lor. Cannot.
Oh, hydroxide.
That's what I said, right? Hydroxide from the alkali, right? Seriously? Okay, another 10 seconds for those who are trying. Chloride and nitrates are both anions. How do they exist at the same time? Not possible, right? Okay, please. We're at our last question. Lock in, lock in. I want to go home on time. Y'all will have to get used to this flow chart. QA, it will always come out.
How does that do this?
QA and acid reactions. This one is considered easy flow chart for QA. You add aqueous ammonia, the alkali. Green is this. Fe3 plus is this. So the PPT is called iron 2 hydroxide. Exposed to air, it gets oxidized. If you leave it to stand, it will turn red-brown. Oxidized means from 2 plus increase to 3 plus. Okay, that's oxidation, which you will also learn later on next time. Then on the other side, acid, silver nitrate. Usually when you see this, acidified silver nitrate is always an ion test. And in this case, you get white PPT. Silver is always test for halides, remember? And if it's white, it's chloride. If it's yellow, it's iodide. Then what is this green solution? You know that it originally contains Fe2+, right? And you also know that it has this anion inside. Then you mix with an aqueous solution plus, it doesn't react with acid, right? Because it's a salt. You add with another aqueous solution. You exchange the partners again. It's like precipitation. Aqueous, you mix together, the ions just hang around, and then if they finally find someone and the AgCl is solid, the rest of them, Fe and NO3, still hanging in the solution. Fe 2 plus and O3 minus. Okay, so they ask for names, not chemical formula. In solution B, I said already, right? I said name, right? Just now, not listening. Okay. Find in solution B. Okay, so how come got these two extra in solution B? Because you added in silver nitrate in excess. Construct chemical equation. Which one? Acid plus, wait, let me see. The nitric acid, H plus. Then the NO3 is already here, right? Then the silver, the nitrate is the same thing, but the silver is also there. Ag plus, extra. Okay? For C is silver chloride, okay? Then the same thing as just now, just exchange the partners. Make sure you balance the equation. That's the only two things you need to check for when you write equation. Balance and the state symbol. Then the ionic equation is the one that I mentioned just now. You just add the OH from the alkali. Okay. If you're done with this, then the MCQ, you'll just go home and do, okay? Later on, I will show you the QR code for the answers. But before you go, yes, the Google review, okay? So what I need you guys to do, okay, this one done, I'm gonna move, Okay, before the full scan, I just quickly run through, right? For next year's class, if you're interested to join, for you guys will be Sect 4, right? If you sign up early enough, right, then you will get all these perks, okay? But what you can do is, this is just interest form. That means you indicate your interest, you lock in the perks, but let's say you discuss with your mommy and like, okay, maybe I don't want to go already. Then it's like, fine, okay, no loss. But if you indicated your interest and next time you decide to sign, you will still get all these perks, okay? So for those who are interested, you just scan. If not, we will move to the full scan paper, yes. Okay, anybody needs this? The interest form? No? Okay, then I skip to... Okay, so you will scan for the Bukit Timah since we're here. Just leave a short review, whatever it is, okay? Just don't write weird things. Write whatever you want, but not anything weird. And then you just come to the front, just show me your review, and then You just take your first step and you go.
That's pretty good.
Fast game, right? Okay, looks like you guys want to go home on time. No, but I think you show you the answer key later. So you don't go first. Okay, you can pack up while you take this. Alright. Anyone else? Cannot scan? Doesn't work ah? Then you just search on Google lor, Overmug Bukit Timah. Anyone else? Come, pass to back behind you. Okay. Okay, yours. Pass to the back. Yeah, behind to the Pass to your side. Your row. Anyone else? 1, 2, 3. Pass behind. All the way to the last row, please. Pass to your side. Okay, no one else, then I will flash the QR code for wait ah. Yeah. Oh, didn't get ah. Wait ah. You wait ah.
You put it separate.
Okay. Scan from here the QR code for the answers. Scan from here the answers. Okay, I will shift later. Scan first. That's the answer, right? You check. That's the answer, correct, right? Does it work?
Yeah, give me a number, I'll send it to you. You got your number. Huh? I do not have his number. I do not have his number.
Doesn't work ah? Or airdrop ah? Wait. I see if I can airdrop.
I don't have You do that.
Yeah. Wait ah, download. Okay, whoever needs your on your airdrop now. Janoria. Who else? Nobody else needs the answer. Okay, already yeah. Everybody got already yeah. Then you'll just go home and try and just do on your own. Mihira, need the answer? Have ready? Okay. Okay, if you're done, then you guys can pack up and leave already. Okay. Yeah, you scan yet? Okay, then just pack up and leave. Clear all your snacks also. I need to lock up the place, so yes. Thank you. Bye. Thank you. Yeah, I decided to have class at 8. Because you added active, right? And then because it didn't react away with anything else. Because CL doesn't react. See if the H plus, NO3, excess, Ag plus, and NO3 as well. So all this that is not found inside here, the H plus and Ag are considered inside the solution here. Everything is in solution, right? You just pour everything together. So only this precipitate, I solid, the rest all remain in the solution. Which part is from the acid, natural alcohol? Type on your way out. Yes. Yeah. Oh, because it's alkaline. So in solution form, like microscopic, and in compressed it's alkaline. Yeah, in water. When you so you know that ammonia gas alkaline gas, right? Put it in water, you get aqueous ammonia, which is an alkaline, and it has pollutants. Yeah. Yeah. Thank you. Bye.